For those who are new to tools like AWS, some of these concepts may feel a bit unfamiliar. But don't worry, I'll walk through each component step by step to give you a high-level overview of what's happening, and we'll dive into technical details later on in our learning journey. To begin, let's talk about the collaboration that happens between data scientists and machine learning engineers on the pipeline of a machine learning project. Once any code changes are made, they're committed to source control, and this triggers a series of steps in the CI/CD pipeline, as we discussed earlier. The first key aspect of any machine learning project is the dataset. This dataset is usually prepared by data engineers who create a pipeline to gather and deliver data as required by the project. Typically, data scientists have read-only access to production data, but they have both read and write access to the development storage environment, where they can experiment with new features and data tables. Once the data is available, the next step is exploratory data analysis, or EDA. Here, data scientists analyze the data iteratively, testing and verifying if the data has the potential to solve the given business problem. During this phase, they also start considering what data preparation and feature engineering steps they'll need to apply. Another key asset in MLOps is the repository. This is where we save all the project code, including pipelines and modules created for the application. We generally work with branches in a version control system, so you'll see development, staging, and production branches. In this setup, development work is done within the development branch to track changes effectively. Once all code changes are validated, the version control system allows the code to move from development to staging or production as needed. The next important concept is the feature table. This table is essentially a pipeline that reads raw data and processes it, creating a store of engineered features ready for training. The pipeline usually includes a data preparation step to check and resolve quality issues, and a featureization step where new features are created and refined in the development environment. Once ready, these features are saved in a development storage environment for prototyping. When we're satisfied with the feature engineering, we promote these features to production, making them available in production feature tables for deployment. Next comes model training. Here, you'll create a training pipeline, which includes steps for training, tuning, and evaluation, all while managing the model outputs and artifacts. The process generally starts by reading data from the feature store. The model is then trained using various machine learning or deep learning algorithms, and hyperparameter tuning is performed. The best performing model is then logged into the model registry. Finally, the model is evaluated using test data, and we keep track of the outputs. Once training is complete, the updated code is committed to the repository, and the development branch will have the latest code. After successful integration testing in the development environment, the code is merged into the staging branch. At this point, the project is ready for deployment. The deployment phase starts by testing in the staging environment with user feedback. Once it meets expectations, we commit changes to production and deploy them there as well. This brings us to continuous deployment. Continuous deployment kicks in when the training pipeline finishes and requests that the model be moved from staging to production. During this phase, we verify compliance, compare staging and production, and ensure the smooth transition of models across environments. Depending on the business use case, we might use various deployment strategies, including online serving with REST API, batch inference, or streaming inference. Finally, once the model is live in production, we start monitoring the entire pipeline and system. We track the input data, model predictions, and various performance metrics. Monitoring also covers data drift, accuracy, and performance indicators for the model, as well as computational performance metrics like memory and CPU usage. These metrics are pushed to dashboards, and alerts are set up to notify the team of any issues. We monitor data ingestion, pipeline logs from batch or streaming processes, and infrastructure performance. And to visualize these metrics, we use dashboards created with tools like Power BI, Tableau, or Athena to help monitor system health and perform diagnostics. Another key aspect of monitoring is model retraining. Over time, model performance may degrade, indicating that a retraining cycle is needed. We trigger retraining either on a set schedule, like weekly or bi-weekly, or in response to performance issues detected by the monitoring pipeline. During retraining, the latest data is processed using the project code in the version control repository, and the model is evaluated with fresh data. This process keeps the model updated and ensures it meets performance standards. So, these are the core activities in machine learning projects, especially in large enterprises where MLOps plays a crucial role in scaling and automation. Now, I know this was a lot of in-depth information about machine learning operations. But don't worry, this overview is just to give you a sense of what MLOps covers. We'll break down the technical details of each aspect as we move further in the course. This concludes the theory part. I hope you found this introduction to MLOps helpful. In the next video, we'll begin putting these theoretical concepts into practice with hands-on implementation. Looking forward to seeing you in the next video.